Welcome everyone for our computer engineering subject, software engineering lecture series. So this is the third lecture series session for the topic exhaustive versus heuristic approach. We are going to take machine learning and software engineering with this 10-minute walkthrough session. Okay. So I once again welcome. So software engineering, we have already discussed what is software and different types of software, okay, and why software is needed. Okay, so we discussed also about what is engineering. Engineering is where we are trying to solve a problem, and even the existing problem, we are trying to make it better by providing it to some alternative best choice. Okay, so on that approach, this topic comes up, exhaustive versus heuristic, where computer engineers definitely should know the difference between these two approaches. So the difference between solving a problem of the exhaustive approach and the heuristic approach are guarantees that the best possible answer you will get, that the other gets you by this end of the video, that with these two applications of machine learning and software engineering, you will be able to identify these two basic but very, very useful approaches of writing an algorithm, of computer engineering, scientific approach, and so on. So the exhaustive approach means you search every room, every drawer, every packet, okay, every places you already checked. Okay. It's a guaranteed that you find that particular item. Okay. For example, it's on the screen that you search every corner of the house and you get it. Whereas heuristic approach, you check the most likely spots first, near the door, the dining table, yesterday's clothes, your handbag. Okay, so this is much faster, usually successful. Why it is said usually successful? Because you may never know that you land up to the last corner where you get the item. Okay. So may miss the keys if they are somewhere unusual. So for example, how we relate this is that if suppose we have books in the library and they are ordered in an alphabetical manner, right? So if they are not ordered in an alphabetical manner and you want to search a book, you have to start from one. And if suppose there are 1,000 books, you have to end it till the 1,000th one. Okay. So how many turns you will require? 1,000. But as far as this heuristic approach will be concerned, you may have to take an extra time on sorting the books as per alphabetical order. And once you know the starting alphabet of the author or the title of the book, you can directly go to that particular section. So in these two cases, which is faster, the one which is sorted, but the additional cost is that you have to keep the data sorted. Okay, right? So if suppose you, even if it is sorted by alphabetical order and you don't know it, and if your author starts from Z, so you may land up to at least 900 iterations if you're going for exhaustive search. But if you are considering heuristic, you will directly go to the Z author list, which it starts for. Okay, in machine learning, often deals with millions of possible solutions. So, how do you do the hyperparameter testing? Is that first you have to do the tuning. So you see the model has 10 possible learning rates, say 8 batches sizes and 5 optimizers and 20 epoch settings. The people who know machine learning will relate to me. Multiply those together and you get, 8,000 possible combinations, right? So the exhaustive approach called a grid search trains and evaluates the model on all the 8,000 of them. It will find the best combination. Okay. So it's extremely slow and expensive, and you will have to utilize a lot of GPUs. Whereas the heuristic approach, okay, what will the heuristic approach it will do? So it will use methods like, random forest algorithm or maybe Bayesian optimization or early stopping. So instead of trying 8,000 combinations, you might only test 100 smart ones and still land up within about 99% of the best possible uh, accuracy in a fraction of the time. Okay. So one more simple example. Okay. Those who are beginners, whether it's machine learning or software engineering, I would relate this topic to like multiplication. Okay. So if you are doing multiplication, you will use the pen paper method, right? And you will understand the technique. So, but humans, what they do after 10th or 20th problems, they may light up into error because you are doing it manually, correct? But if you understand the pattern of how to write that particular multiplication, convert it into steps, convert it into computer algorithm, feed it as a machine learning, okay, pattern. Okay, what is machine learning? You make the machine learn. So, what's the best way? Feed the algorithms. So, create an algorithm to multiply two numbers, feed the algorithm, and what you get that you can do as many multiplications you want, maybe 2 lakh, 20 lakh, crore. But computer will give you the accurate results because it doesn't get exhausted. So, if you want to do something repetitively and it has a pattern, okay, first try to do the exhaustive way, that is, do the pen paper method. Then try to convert it into an algorithm. Okay, put it into a program using any of the language, programming language. Okay, and then with multiple inputs, you can have the accurate results. So that is called the heuristic. One more example I can give you is that simple, so that you understand this concept of exhaustive and because those for the software engineering learners, these concepts may sound a bit difficult. Okay, for example, if it is machine learning, feature selection and decision trees. Okay, so if you have a data set, say 500 features, the number of possible subsets is 2 to the power 500, and astronomically large number. Checking them all exhaustively is simply impossible, right? So instead, we use heuristics like forward selection, backward elimination, recursive feature elimination, or genetic algorithm methods that intelligently narrow down, the promising feature subsets. I also have my own research paper on feature selection rough set theory using data mining as a framework for rough set theory, where I have used these heuristic algorithms. I had used a mushroom plant data set, okay, where if you want to pluck a mushroom plant, the data set had 23 attributes. So you had to think while plucking the plant, remember 23 attributes, and it would define whether the mushroom plant is edible or poisonous, correct? So it's very tedious for a farmer to remember 23 attributes. So using these feature selection means you try to reduce the number of um, features or the attributes. So the research paper I wrote, I landed up to 23 features of the mushroom plant to 3 features. So now, even though you are using 3 features, the characteristics of plucking the plant, identifying into edible and poisonous would be the same. So farmer can easily remember 3 attributes. So that is one of the case studies. So you can go and check out my paper. I'll also share in the description box the link of the paper if possible. Okay. One of the simplest, one more method I will tell you is the phonics. So when an English teacher tries to, you know, make a student learn how to read the words and formulate it. Okay. So the exhaustive search would be that suppose if there are 1,000 words, let him or her student, mug up the words by, writing it 10 times each and so on. 1,000 words. Possible? Not possible. He may land up to after say 15 words, he will not remember the previous ones. And it will take a lot of time. And it's very frustrating after a certain time for a student and also for the teacher to have it. Another teacher uses the heuristic approach where the teacher tries to teach the phonics to the student. What is phonics? You can just check on the Google if in case you do not know in detail. But just in brief, I'll tell you that with the help of the sounds, how to join the letters and then try to identify the spelling of the word. Okay. So what will happen if you understand this technique? That's as good as an algorithm, steps, how to, join the phonics and all that. And finally, you can make infinite words, not even mugging up one of them. So, which is better for a teacher to teach an exhaustive approach and a heuristic approach? Of course, for a teacher also, a heuristic approach. Similarly, if you want to add two numbers, you keep on hard coding it as a programmer. That's exhaustive approach. But to create a function to add two numbers, you can replicate it in n number of projects and n number of times. Clear? So connecting to one example of software engineering here, there are in the SDLC lifecycle, which you will be learning in the upcoming sessions. So you have to do a testing of your particular product or a project. Okay. So there can be n number of test cases you need to generate and test it. Sometimes if you go for a manual or an exhaustive testing, you may land up to skip some of the case studies or the pathways of the coding or maybe the product life cycle or the system testing. Correct? But if you use an heuristic approach where it should go to every node, okay, if you try to create your project as a flowchart in the form of tree, graph, or an extensive data structure, and every path it should go, every node, every edge, so that you do not miss any of the testing phases, and the loops or maybe any of the edges, if you can relate. Okay. So heuristic approach would be used very extensively and in a very efficient manner in the testing phase of the life cycle. Of course, we write algorithms in the implementation phase that also will be a part of heuristic approach. We use design patterns already existing and we try to incorporate it in our design so that we do not want to start from scratch. That is again a heuristic approach. Okay. So remember the two simple examples which I gave, the phonics one and the multiplication one. That would make you identify what is exhaustive and what is heuristic. Okay. So when you will go into detail about the test case generation and, bug localization, then line by line, you should not skip any of the code if you're using LOC. Or if there are function points, when you learn the project metrics, you should not skip any of the function metrics also. Okay, so that all risks are covered. And what is equivalent partitioning? Equivalent partitioning is you convert your root node into different left tree and the right tree, like a data structure. And then, you cross the every node and the edges so that you don't miss any of the uh, uh, if then else or maybe loops. Okay, while testing. करेक्ट सो अगर इफ के अंदर इफ है या फॉर के अंदर फॉर है या इफ के बाद फॉर है या the combinations of a programming, so it should not lose during testing any of the permutation and combination, what I'm trying to say over here. Okay, so at a glance you can just differentiate between exhaustive and heuristic. So it finds the optimal solution, whereas it finds the good enough solutions quickly. So of course, this will give you the best thing, but it will take time. For example, 1,000 books, you need to start from A to first to the 1,000th one. Whereas if you sort it, it may happen that you may have to go here and there in between, but then the access would be faster. Okay. In terms of library, the example I give you. Okay. Accuracy, as I said, it will be optimal because you will not, but this will be moderate too high. But of course, if you need accuracy also in a faster access, heuristic approach would be comparatively better. Because exhaustive approach, I told you multiplication. After that, it may become frustration and accuracy also may degrade, right? Complexity, of course, it's very high in exhaustive. As I said, 1,000 books, 1,000 complexity. Whereas in heuristic approach, if there are, say, only 10 books starting with Z, then you have to only go directly to the Z block. And maybe you need to scan 10 books instead of 1,000 books. So see how much complexity gets reduced. Okay, see, if you do not understand a topic, if you think that I'm going faster, just rewind the video. Okay, and you may try to relate it. Fine. Scalability, that means number of users. So obviously it's an exhaustive approach. So it's poor for the large problems. Whereas since you are making an algorithm, it hardly matters how many number is. And then practicability, suited for small search spaces. Okay. But when it comes to complex problems, then definitely heuristic approach is anytime better than the exhaustive approach. Okay, so just giving you the real world examples. Chess. So if you use the exhaustive approach, evaluate every legal move. Whereas if you use the heuristic approach, okay, if you write to algorithm for the chess, if you use the heuristic approach, you can use the alpha zero, which evaluates only promising moves. Correct? So if you want to go in detail, you can just check out more. I'm just giving you the glimpse of the real world examples with some terminologies. Okay, if you're interested in each of these real world examples, you can just comment and I will be happy to make a video for you, or any of the problem statements on which you are working, whether it is machine learning or software engineering. Then another example, Google Maps. For exhaustive, check every possible route. For heuristic, use A star search, finds a great route fast. So computer engineering students, you learn algorithms, you learn data structures. So whenever you learn those structures, just remember A star algorithm. Okay. Um, it is the best suited to find the shortest route. If I want to summarize it in one line. Real world example, another one, Netflix. Exhaustive approach, compare every movie, use a pair. Whereas heuristic, collaborative filtering, ranks likely favorite. So if anybody seeing this video who is learning who has already studied the subject machine learning or introduced to the subject machine learning, okay, then definitely you will come across machine learning algorithms like collaborative filtering. So even if you are a machine learning subject or software engineering course, this video will be useful to both of you. Okay, because nevertheless, even if you're software engineering new learner, finally you will land up to machine learning one day. And if you have already learned machine learning, then definitely you shouldn't have skipped the software engineering life cycle. So they go hand in hand. And then Amazon search. So exhaustive search, compare every product, whereas in heuristic, you ranking algorithms surface relevant items. Okay. A simple example of data mining and machine learning that is called as market basket analysis. Okay. It is MBA short form. What does that mean? When a person goes to buy bread in a particular store, it's quite likely that he may buy eggs, or he may buy jam, or he may buy butter, because what you eat generally with bread, those items. So if that particular store is keeping bread but not keeping the relatively associated items, the person may land up to, okay, that time he may buy a bread and maybe go to another person and buy the other items. But once that person comes to know that in the other shop they get all in one place, probably next time it will not go to the previous shop. So you understand? So that is called a ranking algorithm service relative items. So relative items. So I just told you with bread, what are the relative items? The jam, butter, eggs, etc. Okay, so that is MBA is used, okay, to attract customers so that you understand the needs, okay, of the customer in a faster way. Why faster way? उसको दो दुकान में जाने को टाइम लगेगा, एक ही दुकान में सब मिल गया, तो why not preference, right? Because heuristic approach, what were the benefits of heuristic approach? Faster, accuracy is better. Okay, अगर उसको कुछ रिटर्न भी करना है, अगर दोनों ही आइटम में कुछ डेफिशिएंसी और रिटर्न करना है, तो उसको दो शॉप जाने के बजाय एक ही शॉप में जाना पड़ेगा, एंड सो ऑन. अगर उसको डिस्काउंट मिलने वाला होगा तो दो में कम मिलेगा, एक ही जगह पे जाना मिलेगा, मे बी ही मे अवेल सम ऑफर्स एंड सो ऑन, राइट? So on the screen, as the previous related topic of comparison between the two, you can also relate the advantages and disadvantages. You can take the screenshot and relate it with the previous slides, and definitely this would be the takeaway of your both approaches, and very confidently you will be using the heuristic approach. But yes, always don't forget, whenever you start with an heuristic, you want to develop an algorithm, which we call it as a heuristic approach, you should start with the exhaustive approach. Without knowing how the multiplication works manually, how can you write an algorithm on it, right? So that you have to take into consideration. But that doesn't mean that you're going to solve 50,000 pen paper method and then land. You can take 10 examples, take it as a confidence. If you're not 10, take 15, okay? But or maximum 50, but not 50,000 you need to do that. Okay, but finally, when you create the same thing into heuristic approach, it can go into 50 lakhs, 50 crores, no end to that. Okay, so it's a trade-off, not a contest. So exhaustive approach guarantees the best solution, but are often infeasible because of the enormous computation effort required, whereas heuristic approach sacrifices guaranteed optimality for much faster execution and better scalability. Okay, so I'm not here to preach about heuristic approach. I've just given you a brief about these two, and both of them are important. I'll again repeat, without understanding the exhaustive approach, you can't land up directly to heuristic approach. So I think the short session on heuristic approach versus exhaustive approach would be useful, especially to the learners of software engineering and machine learning. But however, this concept is useful for every stream, okay, particularly in our computer engineering and AI. But you can relate it to every stream where you understand the benefits of. Okay, so thank you again for watching. And if you have any doubts, you can comment. And also, if you like, you can just subscribe and share. So this is Dr. Aisha Butalia signing off from this session.